Okay, we still have one more speaker. We have the cameo appearance of Dr. Bob Willis from the University of Michigan, directed the HRS study, and he has some really interesting data that we're all very excited about.
Okay, thank you very much. I'm, I think, maybe the only economist in the room, so a lot of vocabulary is out of my range. But I've really been fascinated by this, and have been indeed fascinated by the field of cognition for the last decade or so. What I'm going to be talking about is the effect of retirement on cognitive performance. And the background, and basically what I'm going to be, a paper that I published with Suzanne Rohwedder in 2010 called Mental Retirement, used data from the Health and Retirement Study, and which is a very large study that many of you will be familiar with, and if you're not, you can find out elsewhere. and you're in a family of studies in Europe, in England, and in 11 European countries. And what we found in that paper was that the memory score declined when retirement took place. And what one found, and you can see in this picture, a relationship between retirement, the percent retired on the horizontal axis, and the average word score of people in the different countries on the vertical axis. And in order to try to control for any kind of reverse causation in this, we used instrumental variable techniques, which made use of a landmark study in economics that showed that almost all of the cross-national variation in fractions retired was due to differences in policies that either discouraged or encouraged retirement. And that then we used those policies as instrumental variables to try to get a causal effect. The negative effect of retirement, which we found, was consistent with the joint hypothesis of use it or lose it, which is that the idea that greater mental exercise or stimulation preserves brain health, and the other hypothesis that working life is more mentally stimulating than retired life. Now, we were working in the context of a survey paper that Tim Salthouse had written that claimed that there was very little evidence for the use it or lose it hypothesis. However, one of the reasons for that he emphasized was the sort of short duration and small dose of the studies that had been done. We felt that retirement is a big dose, and the difference between retired life and non-retired life would be important. Now, more recently, I've been doing work with Laura Carstensen and some other co-authors on the effect of retirement on cognition. Is it affected by the cognitive complexity of occupations? And for this, I'm using the Health and Retirement Study, and I should mention that the HRS and all of the other studies in the previous slide are population representative, and they're longitudinal, and they're public use. So people in this room as well as other rooms can use these data. We use the same measure of cognitive performance as in the previous mental retirement paper, which is episodic memory, immediate and delayed word recall in 0 to 20 points. The samples are only people who have normal cognitive function at baseline. The outcome variable is the change in cognitive performance over 6 years from time 1, which was two waves, or about on average 3 years before retirement, to 3 years after retirement at time 4. And we use the difference measure really to sweep out any permanent differences across people, and basically we found the same thing as was presented earlier, that when you do first differences, you wipe out all of the differences in levels by education, for example, are completely wiped out, and all of the declines kind of overlap. What our main finding was that people who were in low occupational complexity had really quite substantial declines in cognitive scores. We're using a method which I won't describe too much, but basically a potential outcomes framework with controls for self-selection into occupation and into retirement. But on the high occupational side, in the lower panel here, there was very little effect of retirement on cognition, and indeed people who returned to work had some positive effects that were marginally significant of increasing their performance on memory. And I think I'm at the end of my 5 minutes about. So if you want to know why cognitively complex occupations are protective, please ask.
Thank you very much, Bob. That was terrific. Thank you.
Hey, Bob. Why are cognitively complex occupations protective?
I deny that I've ever met that man.
Do you work at the White House?
So this is the aspect of things that have really occupied me for quite a while. I'm an economist, and there's a branch of economics that has been in existence for about 50 years called human capital theory. Pioneers of that theory, there are 3 or 4 Nobel Prizes that have been awarded for work in this area, and it provides a framework that really runs from birth to death, connecting sort of early life activities and endowments, accumulation of what we call human capital, which is very closely related to what psychologists call crystallized intelligence. And economists visualize this as a process in which what I learn during a period of time is controlled by a human capital production function, where the inputs are my fluid intelligence, my reasoning ability, or my IQ, however you want to put it, my effort, which is essentially the fraction of my time that I spend learning, and my knowledge, or the amount I've already learned. And I continue doing that from entering kindergarten, or from being at the time I was born until I die in these activities, and there's accumulation and decumulation. Preferences and habits of mind conducive to continued learning are important, and this develops a life cycle path of earnings, and more generally in the literature, health becomes a form of human capital. The time that you spend raising your children and educating them is a human capital production activity, and so forth. So it's a very broad framework, and it has a really well-developed, nice mathematical model. When I started working on the effect of retirement and thinking about the effect of occupational complexity, I sort of ran into the work that Denise and her collaborator, Patricia Reuter-Lorenz, have done on STACK, and also I ran into the idea of cognitive reserve that Jakob talked about earlier, and so forth. And this seemed to me to be starting to provide as it were, a biological underpinning for what human capital people talk about, and in particular what the human capital production function is. Human capital production function already has compensation in it. That is, if it's compensation in the sense of complementarity. That is, someone who devotes effort to, say, learning math or French or whatever the topic might be, will learn more the more he knew. He'll also learn more the more she was able to reason. So the two are complementary, and I think that the evidence now is that complementarity is going on through time. And what people do in human capital is they accumulate this human capital over time, and in that sense, the knowledge is compensating for the loss of fluid intelligence. The underlying process in STACK is really that things that are repeated performance, there's a laying down of durable neural networks. And essentially what human capital is an investment of my fluid intelligence today to create something that's durable. I learned that theorem and I continue to know it later on. There's also a loss of function, yeah. And that goes with what economists call depreciation, and it looks like there are a number of underlying processes, neural processes, that are now being understood in this. The final thing I'll just mention is that I also ran into this work on graph theory and the architecture of the brain, where and it's oddly enough, it's an economic model of the brain. The brain is an optimal trade-off between wiring cost and rapid communication within the connectome. And the architecture of the brain, and this is apparently across species, is that there's sort of a small world architecture in which things that are done together kind of come together, but there's a network of connections across the connectome is very important. And one thing that I have not seen in this literature, but it may be there, is that economists, when we've talked about networks, think about economies of scale in networks, whether it's a hub and spoke system or internet or whatnot. And the network economy of scale means that there are lots of different ways that you can accomplish given tasks. Okay, so that's kind of the line that I was taking.
All right.
Thank you so much.
So Molly and I were sending email back and forth. We're actually going to continue the session until 5:45. Okay, so if there's other similar general session questions, we can handle those now.
Okay. Okay, thank you for a great talk, Bob. Thank you.